In this video, we are going to do something called solving for a right triangle. The idea is that you're going to be given a triangle and you're going to be told some of the information of that triangle, and your job is to find everything that's missing. Now, I just used the same copy of the triangle here 4 times here. It's not going to be to scale at all. So, one of them I say is the value 3 here. It does not mean that all of them are 3 in the hypotenuse, just because it's easier to keep one picture at a time and not worry about if they're exactly the right lengths. Just keep that in mind. So on this first triangle, I'm going to tell you it's a right triangle. We have a right angle there. And I'm going to tell you the hypotenuse is 3. And I'm going to go ahead and say that this angle is 20 degrees. Now your job is to figure out any angles that we don't know already and any sides that we don't know already. If this was a 45, 45, 90 right triangle, we could get the answer using those special triangle rules. If this was a 30, 60, 90 right triangle, we could use those special values to get the answer. But it's not. So instead, we're going to use the trigonometric functions we have learned about, as well as our calculator to help us in order to figure out these missing sides and angles. Well, the first thing we can do is we understand that if you add up the 3 angles of a triangle, it always adds up to 180 degrees. That's a fact from geometry class. So if I call that value x there, I'd have x plus 20 degrees we know, plus the right angle 90 degrees equals 180 degrees. So that means if we solve for x here, we get 70 degrees. So we found our missing angle. Now our job is to find the other missing sides. I'm going to go ahead and call them x and y here. It doesn't really matter what letters you use. And we're going to go ahead and use SOHCAHTOA to help us get the answer. So if you remember what SOHCAHTOA was, SOHCAHTOA. So the first one is that sine is opposite over hypotenuse. So we know this angle is 20 degrees, so we would say sine of 20 degrees is the opposite side, which is y, over the hypotenuse, which is 3. And if you solve for y by multiplying both sides by 3, we get 3 times sine of 20. And if we put this in our calculator here, keep in mind that when you're going to use your calculator, you need to make sure you have it in degree mode, not radian mode, when we have our angles in degrees. So it's going to be some long decimal. I'm going to round it to 2 decimal places. So we have 1.03. So that means this missing side up here is 1.03. And I can do the same thing to find the x. So instead of using sine, though, I can use cosine of 20 is adjacent x over hypotenuse 3 multiplied by 3. And we get 3 cosine 20 degrees. This time I get 2.82, once again rounding. And now I have all missing sides and all missing angles. Now that first example, I gave you one of the angles and I gave you the hypotenuse. So this time I will give you an angle. Let's say this is 40 degrees, and I will give you one of the sides. So let's say this is 5 over here. So I'm not giving you the hypotenuse this time. Now, similar to before, we can get the other angle here, and instead of actually writing it out, we can think about, okay, this is 90, this is 40, it's 130. What do I have left? I have 50 degrees left to fill out my triangle. I can go ahead and call this side x and maybe this side h for hypotenuse. Then I use a trig function to figure this out. Now if I'm using 40 degrees here, if I did cosine, I'd have x and h. That's 2 variables. I can't solve that. So I would need to make sine of 40, because that gets me the opposite side of 5 over the hypotenuse h. Now when I multiply by h to call the fraction, I have 5 equals h times sine 40 degrees. And then I will divide both sides by sine of 40 degrees now. And I get a hypotenuse. So phi divided by sine of 40. I get a hypotenuse of 7.78. So we now know that value. And what you could do is you could use this value of hypotenuse and use cosine to find x. It's better to not do it this way though, because if I use 7.78 for h, and I go through and I solve for x using that, the problem is that 7.78 was already rounded. It's not the exact perfect right answer, it's only a close approximation. So if I'm a little bit off on the 7.78, and I do my calculation, the x is going to be off by even more now. Whereas if I instead use this 5, this number that we were given as the exact right answer, I will be able to only have one step of rounding, so it should be a little bit more accurate this way. Now, what trig function can I use that will have this 5 and let me solve for x? So that trig function would be tangent. Tangent 40 is y over x. And again, solving for x, I get 5 over tangent of 40. Go ahead and put that in my calculator here. And I get x is 5.96. Again, I'm just consistently doing things at 2 decimal places. And now we found our missing side and missing angle. So the first example, we knew the hypotenuse and an angle. Second example, we knew one of the legs at an angle. Both of them weren't too bad. Now let's go ahead and give one where I give you 2 sides. Let's say I say this side is 4 and this side is 2. So this time I didn't give you any angles other than that we have a right angle here, 90 degrees. So we're not going to be able to just, say, okay, the total angle is 180 and figure that out. It's not going to help us. So let's see how we can solve this triangle. Well, one thing I can do is I can go ahead and call this C, hypotenuse, sorry, H for hypotenuse, my bad. And I can use Pythagorean theorem to solve for it. So I would have 2 squared plus 4 squared equals h squared. That's going to be 20 equals h squared. H is equal to the square root of 20, which, if we put it into a decimal approximation, since that's what we're doing on these problems, that would be approximately 4.47. And then you might say, well, we're stuck here. We can't actually figure out the angles. But what I'm going to do is I'm going to go ahead and call this angle theta. And I'm going to use tangent of theta. Y over x is 2 over 4. So tangent theta is 1/2. And what we can do now is there's a button on your calculator that has a tangent to the -1 power. It's called inverse. We're going to have a whole section all about that, how you use it and the limitations of using it. But for right now, we can use that button on our calculator to at least get the angle. So we hit our tangent inverse button, put our fraction in 1/2 inside, and when I hit enter, it tells me that this angle is 26.57 degrees. So we're able to find out an angle here, 26.57 degrees. And once we know that one angle, we can say, okay, what else do we have here? So I could do 180 minus 90 degrees minus 26.57. And we should get 63.43 degrees. And so, in fact, you can still get the missing angles using these inverse trig functions to get the answer. Now, this is something that absolutely requires your calculator. You cannot just do this by hand for whatever numbers you put in there. And as I said, we'll have a later video in a different section that goes into a lot more detail on these inverse trig functions. Now this last example I'm going to give you, I'm going to tell you that one of the angles is 35 degrees and the other angle is 55 degrees. And I'm going to ask you to find the sides here. The problem is you have three sides that are unknown, x, y, and h. And no matter which trig function you use, sine, cosine, tangent, you're always going to have two variables involved in that equation. And you're going to be really stuck trying to solve for any one of them because they all have two variables. And in fact, this triangle is not solvable. You might say, what in the world does that mean? It means that you cannot just find a unique answer to the problem. Because if all you know are the angles there, what could have happened is you could have had a much bigger triangle that's similar to this one. Similar means has the same angles, but has longer sides. And so the whole idea is that because similar triangles all have the same angles but different sides, that means that if all you know are the angles of the triangle, you're never going to be able to solve for the sides because it's not a unique answer. So this is not a problem that I would ask you to do on a quiz or a test or anything like that. Any other combination, side and angle, hypotenuse and angle, two sides, those things can be solved. But you'll never be given a triangle that just has two angles and ask you to solve for everything else. It's not possible.